Welcome to the part number 4 of tutorial Neural Network with Java. In this tutorial, we are going to do a more complicated task, image recognition. We are going to try to recognize a handwritten number. That we will use a popular dataset called MNIST dataset. It is used in many educational and programming exercises. MNIST dataset is available in many formats. We are going to use the CSV format. CSV has 785 columns. The first column contains the actual number that is drawn on the picture. And the rest of 784 numbers represent the pixels. This is how handwritten numbers look like. This is a representation of a dataset in the CSV file. So each row is one picture. Leftmost is the actual number that's drawn on the picture, and all the numbers to the right are the pixels. Pixels 0 means it's white, nothing is drawn, and if pixel has a number, that usually means there is something drawn. So for our neural network, the leftmost number means the expected value that it should predict, and all the pixels are the input layer values. This is somewhere in the middle of CSV where we can see that some pixels have drawn values. Pixels usually use here grayscale, but we are going to turn it into zeros and ones for simplicity. The coding will continue where we left off in tutorial part 3. You can find the code in the Bitbucket in this branch that I posted the link. Classes need to be modified and a couple of new classes need to be added. We have to slightly change how we train the network. We used to do it one by one, so each time we enter a set of data and expected value, then we immediately adjusted the weights. This approach does not work well with large datasets. Therefore, we will use a batch processing way of training neural network. That means we feed data points to the neural network, but only apply the weight changes when we have a significant amount of data points processed. And for this tutorial, I took the average number of all the weight changes. This way we make sure that single data entry points do not have a major impact on the neural network behavior. Let's go to coding. Let's start with the connection class. Here we have to make some changes. We used to keep one pending adjustment value, so we have to change it to the list of pending adjustments, because as I said in the batching explanation, we will have many pending adjustments collected and they will be applied in the end of a batch. So now we don't have getters and setters anymore. We will add one public method to add a pending adjustment value. Now we have to change how pending adjustments will be applied. It's now not anymore a single value. As I have discussed earlier, it will be average of all the pending adjustments that we collected from the batch. So this is how it will look like. We need a new method called getAveragePendingAdjustments. It is going to be a simple method to collect all the data from the list and calculate the average. Just make sure to return 0 if the list is empty, otherwise we will have a problem with division by 0. One more very important change is how we initialize the weights. We used to have next double, which returned the value between 0 and 1. It was a bit of a problem because it is always a positive value. So I decided to change it to from minus 0.5 until 0.5. It is a very important change because otherwise the whole neural network will be biased to the positive number and sometimes it cannot resolve from this. Next, we will make changes to the neuron class. There are only a few changes in the neuron class. We have to update the methods that we call when we add weight adjustments. And the final method that applies the pending weight changes. This will be always called after the batch was done. I would like to create a new class called input-output pair. It will basically contain data from the CSV, corresponding inputs and expected outputs. It is just a container class, so it makes for us easier to transfer data between classes or methods. As I said, this class will have list of inputs as one parameter and list of expected outputs as another parameter. Inputs basically mean what we feed to the neural network, and expected output is what we expect from neural network. During the training, expected outputs are used to calculate the error of the neural network, so we can adjust the weights. Next, we will change the neural network class. This class basically contains all the layers, neurons, and connections. So this class used to have a method called train, which used single entry parameters. As you can see, it immediately applied pending weight changes and also received only one set of input values and expected values. Now we are going to add a new method called train in batch, which will receive not one set of values but multiple. So it will receive list of input-output pair, and the code would be mostly similar to the train function, but there will be very important changes. Create a for loop where we go through each individual input-output pair. Then just copy and paste forward and back propagations. We have to slightly update how we give the input values into the network and how also we set the expected values of the neural network. Because each pair of the batch will have own set of input values and set of expected values. So let's make sure forward and back propagation happens inside the loop. Now outside of the loop, we will need to call apply weight changes. That means we do it single time for each batch. So each batch will have only one weight change. If you look at the top left side in the data folder, I imported MNIST CSV file. This file you have to download yourself and create folder and add it there. And now I'm going to add a new class called file helper. This class will be a utility class that will help us to get input-output pair values from the CSV file. The constructor of this class will accept a file name, which we will give a CSV file name. The constructor will have some lines of code to access the file, to create the input stream, and also create an instance of buffered reader, which we will use to read lines of text in CSV file. After I create the buffered reader, I will read one line. So I will exclude the headers of the CSV file. If you are using any input-output streams, it's best to close anything that is pending. Now we have to add one important private method that will change the expected value, which is in CSV file just a number. It's 1, 2, 7 until 9. We have to change it to array representation, because our neural network output uses 10 output neurons, which each represent a single digit number, starting from 0 until 9. So, for example, if the label says it's number 3, then our expected output array should look like this. As always, please pause the video and write down the code if I'm going too fast. Here I'm just using the given number as an index of an array. So I have an array of 10 items, which by default all have the value 0, and the index would be turned to 1. Now we will create a public method which will return input-output pair by reading a line from a CSV file. So let's remind ourselves, input-output pair returns two values, inputs and expected outputs, two lists. Let's add a try-catch clause. So if something is wrong in the file, so we don't stop the program, we will return null for now. So each time read next line is called, we will read from buffered reader, read line. Next, we split the line to 785 parts. As we know that first element in the line is the expected output, which is just a regular number. So we have to turn it into an array of expected output representation by calling our created method. Next, we have to turn the other 784 values to the list of input array. Here, as I mentioned earlier, I'm changing the grayscale value to simple zeros and ones. So if the pixel has a value of 0, then I will just return 0 here. But if it's higher than any positive number, then I will return 1. So we are not going to use the gray pixel value in this tutorial. Here we just change the array to a list. And finally, we will return input-output pair. Next, we have to update main.java. In this class, we actually run the program, and we used to have a simple example that we did in the part number 3. I'm just running it to make sure that I didn't break anything and everything is working with the simple example that we had. This is not from the CSV file, it's just the random numbers that we gave it. We have to rewrite the code inside main method. I don't want to throw away the existing code, so I will just move it temporarily to another method. So now we are ready to write our main class code. For the convenience, I will create a new private method that will calculate and print out results so I can see how my neural network is performing with the given data. This code basically calculates outputs for the given input parameters and then prints out what were the input parameters, what were the expected parameters, and what were the actual result of prediction by the network. Feel free to pause the video and copy the code. I would like to add another convenience method to get the batch from the file. As I discussed earlier, we are going to feed input-output parameters in batches. This method will accept a file helper instance and a batch size. So we basically will call read next line of file helper as many times as we want in the batch. And if we see that the result is null, we will just break the for loop. Then return the collected input-output pairs. Now we start actually writing our main code. First, we need to create a neural network instance. So it accepts three parameters: input count, hidden count, and output count. So input count is 784, it's number of pixels. Hidden count, we choose 100. And output count is always 10 because it's number of digits from 0 to 9. Then we need a file helper instance, and we create a new file helper and give it the file name. Make sure you create a data folder and add your file. Next, we will create a try and catch clause. Because file helper is using input stream, we have to close it when the program is done. And let's just log the exception for a good measure. In this video, I'm going to use only one batch. We could technically want to use as many batches as we want, but for demonstration, I will only create one batch. Let's have a batch of 100. Let's make sure that batch is not empty before we start. Now, before I start training, I want to see how neural network is performing before I train it. So I log some messages, results before training. So I will just pick the first two items in the batch and print out how they look like in the log. You can add more examples if you want. Now, neural network can be trained multiple times with the same set of data. So by using this batch, I'm going to train it 100 times the neural network. This is also called epochs. And now let's see how neural network is performing after it was trained. So for the first try, I decided not to use 100 batch size, so I decreased it to 10 to make it fast. And also number of epochs I changed to 10. Now let's run the program. Here are the results. It was very quick because we used a very small batch and small number of epochs. Results do not look good at all, so I have to change something. First, I would like to change the learning rate, which is currently 0.5. And I also want to move the static variable into the main class because I want to be able to reach it easily. Let's quickly fix the error inside connection.java because learning rate is in main.java now. And with that small change from 0.5 to 0.4 learning rate, let's run again. And now let's look at the results. Still not looking good. Let's try to train a little bit more. And I increased number of epochs from 10 to 40. Let's run and see the results. And now we see much more improvements. It's more confident and predicts the correct value now. Now, since number of epochs matters, I want to make it 1000 and run again. It will take some time, so I will cut short the video to see the result quickly. Now results look much better. It is almost precisely predicting what's the number on the picture. Instead of showing some arrays with numbers, I would like to show more meaningful information. So I would like to slightly change how we print out the expected and result values. I will add a couple of some small methods to visualize these arrays into some kind of readable numbers. So first expected value, then predicted value. Just stop the video and copy the code. Now let's use them. So remove this printing out of arrays. So instead we will print out the expected value and the predicted value. And now let's run the program. Let's decrease from 1000 to 100 so we get the results quicker. Yeah, this is much better. So results before training, they are showing wrong prediction, expected 7, predicting 2, expected 2, predicting 6. And after training, it's predicting 7 with 84% confidence and 2 with 87. Let's see a bit more results. So I'm looking at the top 5 lines of the code, lines in CSV. Run again. So we have predictions before training. It looks incorrect. And after training, so before training, it's completely incorrect. And after training, it's doing a good job. With 7, it was 73% confidence. So I guess we could still increase number of epochs or batches to improve the neural network predictions. So we have built from scratch using Java kind of image recognition. I know that this is mostly numbers, but it's actually showing that it is working. And we can be happy about that. So to make small conclusion to this long video, Java can be used for AI development, but however, current implementation is not very well optimized and it's quite slow. Object-oriented programming also can be used, but you can still understand why most people prefer Python and libraries like NumPy, Panda, because they are much more efficient to perform matrix operations or data operations. I'm currently thinking what to do next with this neural network project. I could run more training with NIST dataset, optimize the neural network, so the code works very well. or better than it is now. Maybe I could visualize, like print out what numbers look like and what neural network is predicting. Or also maybe I can think about other AI related programming topics. Right now I have few things in my mind. Let's see if I have motivation or time. Have a good day and see you.